Hi everyone, I'm Ashley McManus, Senior Director of Global Marketing at SmartEye. Welcome to the Human-Centric AI podcast, where each episode we feature thought leaders doing cutting-edge work in the AI space. A little bit about us. SmartEye is the global leader in human insight AI, technology that understands, supports, and predicts human behavior in complex environments, bridging the gap between humans and machines for a safe and sustainable future. Today's episode features a product specialist at iMotions, Dr. Pernille Boulot. iMotions is a fully integrated, hardware-agnostic software platform that allows researchers to use the power of any neuroscience technology, as well as traditional surveys and focus groups, to gain unparalleled insight into what people actually think and feel. Their customers use iMotions for everything from diagnosis of neurological diseases such as Parkinson's, schizophrenia, autism, and Alzheimer's, to personnel training, UX testing, advertising, and military human research. At iMotions, Pernille consults and trains academic and commercial researchers on multimodal biometric data collection and study design. Pernille finished her BS at UC Berkeley and completed her PhD in Neuroscience at Emory University, where she studied brain mechanisms associated with the neurodevelopmental disorder Fragile X syndrome. Pernille is passionate about sharing her knowledge to help others create groundbreaking science. Penny and I talked about the use of biosensors in development, particularly in infants, some examples of where tools like eye tracking can be applied in mental health research, and how this technology can help the neurodivergent and neurotypical thrive. Let's listen in to learn more. Okay, hi everyone, and thank you so much for joining us today. With me once again, I have Dr. Pernille Boulot from iMotions. Thanks for making the time to speak with me again.
It's my pleasure.
Awesome. Okay, so let's dive right in. I'd like to go a little bit deeper into what you did with your PhD project. You had briefly mentioned it in an earlier podcast, and I was hoping you could talk us through that a little bit more.
Yeah. So most of my work during my PhD focused on neurodevelopmental disorders and learning what are some of the ways in which the brain develop differently in those people. And I was particularly interested in figuring it out in the context of the symptoms that are very debilitating for these populations of people. So, for example, people with different types of autisms or Fragile X syndrome, which is a neurodevelopmental disorder, cerebral palsy, they all suffer from a variety of different symptoms that are obviously related to cognitive abilities, but then also, for example, sensory sensitivities. So some of these people are super hypersensitive to sound or touch, and that can totally impair their ability to hang around in social circumstances. Like having a birthday party is not really simple any longer, and something a lot of us can take for granted. Going to the movies becomes an overwhelming experience. So the overarching mission of my project was really trying to figure out how can we understand that process better at a biological level so that we could potentially find ways therapeutically to alleviate the most debilitating symptoms that these people live with daily.
Very cool. And we talked about biosensors and mental health, but I think to this point, we've mostly focused on adults. So maybe for this conversation, I really wanted to focus on mental health during development. So, how are biosensors being used there?
They're being used in a lot of different ways. And if I were to try to categorize them into some different groups of ways that they're being used, I would say that there's a huge amount of work that's been done with using biosensors to diagnose or identify early on what's going on in certain patient populations. So this could be, for example, diagnosing autism at a very early age. Then the second category would be more focused on how can we improve or assess the function of new treatment therapies, for example. And then the third group that probably aligns more with what the mission of my PhD project is like, how do we alleviate some of these very debilitating symptoms, and how can we use biosensors in that process to identify what are the most triggering moments? How can we alleviate them the best possible?
Okay. So let's take a step. I love those categories. So let's take a step back and maybe, for each of them, we can talk through some examples. So let's start with that first kind of category you said: identify, stratify, diagnose. Can you give us an example of what something like that would look like?
Yeah. So that has been done for a long time. It's really not that new, especially in the field of autism, using, for example, eye tracking to try to identify if a child of 6 months old is at greater risk of developing autism is something that's been pretty well established by now. It's still being researched. It's not out there in the clinical rooms, which is a shame. We would like it to get out there. So that is an excellent example of how biosensors can be used for early diagnosis. It can also be used for improved diagnosis. So, for example, there are studies out there where the traditional methods of analyzing infants' behavior, which is actually a really good predictor of whether or not they're going to develop cerebral palsy, it misses a subgroup of people. To keep it a little bit more simple, basically there are some infants that display a very specific type of stereotype behavior that predicts very highly whether or not they're going to develop cerebral palsy. But a small group of infants do not have those characteristic behaviors, and yet they're going to develop cerebral palsy. Okay. So there is a specific need for helping that small population so that the interventions can be done earlier on. And so they're using additional biosensors in some of these studies. They're using heart rate monitors to monitor, okay, are there any similarities between the full group of cerebral palsy infants, even though some of them don't display this typical behavior profile. And so that's a way where the biosensors can be used to improve diagnostics and not just make it, earlier.
Okay. And as you were talking, I have a technical question for you. So when you're talking about infants and biosensors, you mentioned heart monitors. What are some other biosensors that are used with infants? I'm just imagining these itty bitty babies with a skull cap or something. What exactly is being used on these tiny infants?
Yeah, no, that's a great question. And there are the more traditional ones, which is an eye tracker that's sitting in front of them.
Yep.
And they're looking at a screen. Mm-hmm. And hopefully the infant is looking at that screen too. And then they're tracking whatever is on the screen, right? It could also be that there is an eye tracker in front of them, and then there is a human face. And then you're looking at, okay, how much are they looking at the human's eyes or their mouth or aspects like that. Okay. With rate, it could be actual electrodes that you place on their body, which is done in some of the older studies for sure. But now with new wearable technology, there are actually studies out there that are assessing the quality of a wearable watch, for example, to monitor heart rate in infants. And they are pretty good at that, according to some of these different studies. So there are different ways. It's constantly developing. So there are the more traditional ways, and then there are the newer ways with wearable technology that's coming out there. Obviously, with the infants, we really talk about early intervention, right? So earlier we can diagnose, the better the intervention can be. But we're not just talking about infants here. We're also talking about children that are 2 years old, 4 years old, 6, 13. And for them, there is a ton of other options out there that align much more with the idea of what we think of as adults. So eye tracking glasses are being used to do highly ecologically valid studies to discover whether or not certain children have autism. This is particularly interesting in the populations of people that have autism at a less severe level. Especially females are very good at masking their autism symptoms just through societal and cultural pressure, and also because their symptoms are presented differently. And so these are different types of biosensors that can go in and help specific subgroups of populations to intervene appropriately with what they need. They may have good social skills, but they may need more support in other areas.
Fascinating. Yeah. And it's just so interesting to me too, because especially when you think about the infant group and, these different types of biosensors and what's, I guess, obtrusive and not like, I would imagine an eye tracker that's not physically on their body is a lot, you get more naturalistic data than trying to strap things on them and they don't like it. And they're trying to push it off. So it's just fascinating to think about.
Yeah. No, I mean, the one issue though is that infants haven't learned the magics of the screen yet. So they naturally want to look at moving objects. So usually what researchers will do when they have them look at a screen is like have something dynamically moving. And then they can actually stratify whether or not a child is more likely to develop autism based on what type of objects they look more at when it's moving on the screen. But first, you've got to make sure that they also look at the screen.
Yeah, that's definitely
set up there. And then there's the question of, well, what about remote monitoring? With all of these assessments where it's like a specific eye tracker that's sitting in front of them, you got to come into a laboratory to do that, or they got to come to a little bit more intensive. So the wearables are going to make a huge difference whenever that is more normal in practice.
Very cool. Okay, so I'll dig ourselves out of this hole we're into. So another question I wanted to ask you about was biosensors that assess and improve interventions. Can you talk a little bit more about that?
Yeah. So this is something I think a lot of people can relate to easily. So there are a lot of different types of treatment paradigms out there, right? There's some that are pharmacological, meaning that people get some kind of medication, or it could be a psychotherapy, it could be a behavioral therapy. Now we're also starting to work with things like virtual reality that's actually becoming a more and more useful technology to help people with neurodevelopmental disorders address some of their cognitive and social challenges. So the biosensors in this particular perspective are very useful in assessing before-after states. And also, what do people actually pay attention to during the treatment itself? So, and how do they feel during the treatment themselves, right? So this could be a person with autism, for example, that is undergoing a virtual reality type of game where that is the treatment itself. Then you would want to look at, okay, what are their cognitive functions, their attention functions, their stress states, things like that before, during, and after. And so that's the way the biosensors are being used, which I think it's awesome. And actually, I know we're going to talk we have talked a lot about this, but and we'll end at the end of the session today with it. But we have a webinar in January where one of the biosensor researchers that's going to come on there, she's going to be talking about how she is using virtual reality to improve treatments for people with different types of compulsive and ruminative disorders. This could be children or adults.
Yeah.
But it gives a nice, very concrete example of virtual reality games and scenes and things like that are already being used and being tested. And this is something we always need to make sure that they are rooted in evidence and hard data. You want to make sure that, we come up with these new ideas and these new approaches, but we also don't want to have them just be floating out there without any type of evidence that can corroborate them. So that's really where biosensors come in.
Very cool. Okay. So now biosensors that are used to study how we can alleviate debilitating symptoms like sensory hypersensitivity. What are some examples of those?
Yeah. So it's like it's very similar to what we've been talking about in terms of the technologies, which is nice because the same piece of technology can be used in.
Yeah. Very cool.
One of the ones that resonate a lot with the type of research that I was interested in during my PhD is using biosensors to identify specific moments or periods that are particularly stressful to people with heightened anxiety that is often associated with different types of neurodevelopmental disorders. And so that could be, is it the school ride is it the bus ride to school that's really setting them off on the wrong foot? Or is it the way that they're being interacted with in their, in their recess? Or is it the way they're being interacted with during their lesson? These are the ways where we can pinpoint, oh, this is where we really see there is an increase in heart rate, skin conductance. We hear changes in their tone of voice. Oh, they just started going totally flat. They're mute. They don't want to talk any longer. This is where we can pinpoint, here is a stressor. And that really triggered some kind of event. And if we can then go in and say, oh, okay, now we learned that, can we change it? Can we improve the spaces so that they also accommodate people that have neurodevelopmental disorders? So that's one very concrete example that I obviously really like. It could also be biosensors to figure out, how do people best learn? I think we take it for granted, especially in these more online days after COVID, where everything is happening online, right? That is annoying. It has implications for everybody. It has specific and unique implications for people with neurodevelopmental disorders that are still in school. And that is something that can be studied, where we can see, oh, they are paying significantly less time to online phases versus in real life phases. That might mean that it makes it even more difficult for them to understand what's being said, because they already have a challenge with processing auditory information. They need to make sure they look at the mouth of the person. If they don't, that could reduce comprehension. So these are some of the ways that biosensors can also be used to improve teaching methods, all of that good stuff, which benefits both neurotypical and neuroatypical people.
Mm-hmm. Mm-hmm. Yeah, and this kind of rolls into my next question too. What are some of the ways that biosensors can help people with and without neurodevelopmental disorders thrive?
Yeah. So Rana and I did a live stream recently, and when we talked about wearables and the possibility of wearables and thriving, the conversation went off the roof, which was awesome to see. And I think that is something that a lot of people can relate to. A lot of people are now getting used to monitoring themselves, right? So they're learning, oh, when my heart rate is this, or when I sleep like that, then I feel like this. And when I eat this, I feel better when I do this activity. And that's great. So I love that aspect of thriving. From a research perspective, I think there's a huge untapped potential in figuring out patterns. I'm speaking less about what the individual can get out of a wearable or a biosensor, and more about what researchers on a more grand scale can get out of them. Where in this perspective, they can get information that's extremely comprehensive and as holistic as they would like it to be. Adding more sensors will give you more holistic insight. So I think we have a huge potential to figure out, okay, what are some of the patterns when people have had this stressful experience, or whether or not that they be neurotypical or neuroatypical, does that trigger a session of events that then drives them into a depressed period, that drives them into a tantrum? There was one study that I read where they were using heart rate monitors on children with behavioral difficulties. And these were just general behavioral difficulties, but like pretty bad, right? Like the one where a special ed teacher might be involved. And they could see that a few minutes before the actual behavioral tantrum really kicked in, they had an increase in heart rate. And so imagine if we could do something like that, maybe 10 minutes before, where there's actually time to go in and say, like, hey, are you okay? Ways where we can intervene so we can derail them from whatever is going to shoot them off on the wrong track for the rest of the day. And even if it's just a few minutes before, that can still help, right? But we need that is the type of research that I think can bring a lot of awareness to how can we improve thriving and put it less on the individual. Yeah. So it's less of the individual's responsibility and more of the more system responsibility, right? So it's the teachers are trained to know how to do this. The doctors are trained how to know how to do this, et cetera, et cetera.
Mm-hmm. Great. So we've covered a lot of ground. I'm curious if you have any other kind of final thoughts on this topic or major takeaways based on our conversation for listeners.
Yeah. I think I have two things. One thing, after many years of scavenging and being on top of this literature, something that I think is really missing is a validated way of assessing how biomarkers change over time. So that could be, how does their eye tracking or heart rate change over time?
Okay.
Because people are not the same at any given point. And something we know from neurodevelopmental disorders is that they're really difficult to identify in the beginning. Mm-hmm. They look like really, really neurotypical babies.
Yeah.
And then around 2 to 3 years old, things start changing. And then when they're in their teens, things are really different. And then things change over time. Like, this is not just one static, they always have a cognitive disability type of diagnosis, right? Like, their needs change over time. And the way that we intervene and treat should also change over time. And so that's something that's really missing. My research tried to address that in small ways, and I hope that a lot more people will start focusing on that. It's challenging because it requires longitudinal studies. It requires a lot of funding. It requires people that are not scared of not publishing in a long time, which is totally like the antithetical to academia.
Yeah.
So that's where I think there could be a huge impact. And then something that is more of a research interest, and something that I addressed and wanted to address during my postdoc at Harvard, was this seemingly strong relationship between the autonomic nervous system and brain development. Mm-hmm. And we know that people with autism typically have higher heart rate, beats per minute, and they also have lower heart rate variability. We also know that they have changes in their pupil reflexes. We know a lot of different things about how the autonomic nervous system is not functioning appropriately in neurodevelopmental disorders, but we know very little about how the autonomic nervous system actually influences brain development. It's often taken for granted that the brain is the first thing that's being affected, and then that's going to alter everything else. But sometimes a genetic mutation, for example, could originate peripherally and then affect the brain. And so I think that's something that's really interesting. That's more a basic science thing. If we want to address this head on, it's really not that important. What actually comes first, as long as we identify it. But it's something that I spend a lot of time thinking about.
Nice. Awesome. And also you touched on it earlier. We have that webinar coming up. So I definitely want to encourage anyone that's interested in diving a little bit deeper. We'll link the registration page in the show notes, and people can register and watch recording later. But definitely check that out, because I'm really excited to see some of the findings. Especially, I think we're having a customer iMotions customer come and speak about their work too.
Brian Jacoby, who is a researcher and a therapist over at MGH, Massachusetts General Hospital. And she's going to be talking about all of her research that's using biosensors, including VR, to improve treatments and diagnosis of people with different ruminative disorders. So this could be, for example, obsessive compulsive disorders, eating disorders, intense anxiety. In general, that webinar is going to be a deep dive into clinical mental illnesses and focusing on how biosensors are being used in these 3 different ways that we just talked about.
So cool. Love it. Okay. That is all I have for you, Pernille. It has been a pleasure. Thank you so much once again for taking the time to have this fascinating conversation with me today.
It was my absolute pleasure.
Again, this joint content series featuring iMotions, talking all about the really timely topic of mental health research, has yielded some fascinating conversations. From test anxiety to rumination disorders and everything in between. I can't wait to see more at the iMotions virtual event coming up soon. If you can't make it, make sure you register to get the recording in the show notes. I hope you enjoyed today's episode. Don't forget to subscribe to the Human Centric AI podcast on iTunes, Google Play, Stitcher, or wherever you get your podcasts for new episodes. We're also on social media, so please reach out to us on Twitter, Facebook, LinkedIn, and Instagram to share any feedback you have on the show and weigh in on the discussion using hashtag Human Centric AI podcast. Don't forget to rate us and comment with your feedback to help make the podcast more discoverable for others. Until next time, thanks for listening.